Hello, it's Elixir Code Girl. Welcome to the fifth series of running code concurrently in Elixir. So in this series, we will learn how to stop a task from running. Okay, so you can manually stop a task from running using the task.shutdown of RT2. So you can see that the task.shutdown takes in a task and also takes in a timeout or an atom brutal kill. So it returns a tuple. It can return a tuple of an atom, okay, and a term. A term can represent the output that of the function that you are processing, and also if it's not successful, it can return you a tuple of an atom exit and a term. So the term here can represent the reason for the exit, and in some cases can also return nil. So we are going to see the different output, why we are getting at what point we're getting this different output using the task shutdown. So with the task shutdown, it unlinks the task from the caller or the parent process. It also shuts down the task and also checks for a reply. So let's see this in the interactive shell, how it works. So the first example, so I'm going to demonstrate. So the first thing, I'll start my interactive shell. I already have a project, an ongoing project that we are going to use. So this is the project that we have been using all through the series. If you have been following since day one, that is. Okay, so in here, I'm going to create a task and I'm going to use an existing function. So this function is notify asynchronously with async. So this function will start a task asynchronously and it's going to send message to the given number asynchronously. So the first thing I want to do is to alias this. Okay, that's great. Then create a variable task because we are going to use it since the task.shutdown takes in a task. So I'll need that variable. So do send message dot notify asynchronously with async and give it a number. I can give it 1, 2, 3. So we have started our task. Then the next thing we're going to do is to shut down that task. So we can let the task, okay, so our tasks take like 30 seconds to complete. I can even shut it down, it doesn't matter. And give it a task. Okay, so I'm shutting down after it has completed. I wasn't fast enough, which is still okay. So you can see that we have our reply. So in this case, I told you the first thing is, let's go to our slides. It unlinks the task from the caller or the parent process. So what do I mean by this? So by unlinking it, we can check first if the task is alive. Then after that, we can check if the process is still linked to the caller or the parent process. So the parent process in here is the interactive shell. Okay, so let's do that. So the first thing, let's check if the task is alive or not. We do it by the PID. So the task is not alive, but if we check if the caller process or the parent is alive, that is the task.owner. It's alive. So you can always verify the owner by calling self in here, and you'll see that they match, the PID matches. Then the next thing, let's check on, there's this function I'm trying to remember, that was process.info. Yeah. Let's check if can do process.info. Was I giving it a task? And not a task, the owner PID, sorry. So that is task.owner. Okay, so that you can check the caller process. Okay, so the first thing you can notice here, I was concentrating on this, on the links. So we don't have any links, but if we start this task again, check for the process info of the owner, you will notice that we have a link. It's linked, the task is linked to the caller. So we can verify this PID as well. So you can see the PID matches with that of the task. So if we shut it down, so you'll notice we have shut it down and it has returned nil. So I will explain this later. Then we check the process.info. We don't have any links, so it unlinks it from the caller. Okay, so let me clear this to be less busy. The next thing, it already shuts down the task, which we have seen. The process was not alive after shutting it down. Then it checks for a reply. So you could notice we had two replies. The first one, we had an atom okay, and a output from what the send message does. And then in our last attempt, we had a nil as the reply. So let's see why. So the expected output for Task.shutdown are as follows: the tuple of an atom okay and a reply. So in this case, the process is when to expect this. Okay. So the expected output for task.shutdown operate 2 are as follows. So the first one, you have a tuple of an atom okay and a reply. So this is expected if the process is complete and reply is received while shutting down the task. Okay, so if I go to my interactive shell, so I want to reduce this time from 30 seconds to 3 seconds so that we receive our reply. So what the send message does, if given a number, it's supposed to delay for 3 seconds. I will put a message sent to this number, then return the output of a tuple atom okay, status received, and the timestamp. So once we receive this, we are sure. So if we receive an atom okay and a reply from a shutdown, we are sure that the task was able to complete its process of sending the message to that given number. We can verify that. So we already alias. So let's call our task again. I have it here. So we are given, oh sorry, I forgot to recompile because I made a change from 30 seconds to 3 seconds. Okay, so I'm going to call our task again. After calling our task again, we already have I output message sent to 1 to 3, so we are sure that the task is completed. Then let's call task.shutdown. and give it a task. So we can see the reply that we're getting. So we're having a tuple of an atom, okay? And the reply that we are expecting from this from the function send message. Okay, so let's see the next one. The next output is a tuple of an atom exit and a reason. So this happens in case the task died. Yeah, so the task can die for many reasons, but demonstrating this was a bit hectic. But I want to demonstrate using something like so how can I demonstrate this without restarting the caller process as well? So the way I can think about this, so let's create a task. After creating a task, we can try to call await, which will, okay, await shuts the task down. So in that case, we can assume that the task has died in the process. It only shuts the task down in case if the timeout has been okay. If the task takes a longer time to complete, because the await has a default of 5 seconds. So once the 5 seconds has elapsed, it will crash. So we can use that, then call the task.shutdown. So we are calling task.shutdown when you already know that the task has already exited. So let's try with that. So this is for the demonstration purpose for this, but can also think of something else. There are many reasons which can cause a process to die. Okay, so I will increase our timeout again to be 30 seconds. Recompile this first, then create our task. After creating our task, let's call task.away. So we are sure that it will crash because await has a default of 5 seconds timeout. Okay, so it exited, but I wanted to ensure that we have our caller process alive. So if we do task.owner, that's alive. But if we check the task itself, the task process itself, it's not alive. So let's call task.shutdown and give it a task. So we get a tuple of an atom exit and an atom no proc to mean no process. Okay, now let's move on to our last output. So the last output is nil. This happens when the process is not completed while shutting down and the task is still alive. So the process is not completed while shutting down and the task is still alive. So what does this? We can clear this. I don't have to change we don't have to change the time here. So 30 seconds is good to demonstrate with. I'll go ahead and create our task again. Then call task.shutdown while I still have time. So I'm expecting nil. So this has happened because remember the send message takes like 30 seconds in order to be completed. So we have a delay of 30 seconds. And the task.shutdown has been invoked before before the process has completed, and it cannot get the reply back, so it returns for you nil. Also, the task.shutdown has a timeout default, which is 5 seconds. So that 5 seconds has already elapsed and still cannot get a reply. Okay. So just like I mentioned earlier, the shutdown has a default timeout. So it takes in a timeout, gives the process, and this is supposed to give the process time to complete before stopping. To inform you, this was hard for me to demonstrate because I could not understand how it gives the process time to complete, and this is the reason why. Uh, hmm. So here the send message process was supposed to delay for 30 seconds, okay? Then if we try to shut down, we want, like, if we exit our timeout pass to the shutdown, we want it to, like, give the process time to complete, then try to give us a reply back, and try to reply back. So this was hard for me to demonstrate because I did not understand at what time does it give it time before shutting down, and this is the reason why it was hard. It's hard for me. So I'll just clear this, call the task. So we know it has a 30 seconds delay. I want to call the task.shutdown, give it a task, and maybe increase the time to 40 seconds. Or let me be realistic, 35 seconds. So give it like a 5 seconds extra. Yeah, so it returns nil. I was expecting it to return a reply of a tuple atom okay and the reply back, and the reply that we expect from the send message, but that wasn't the case. Yeah, the other thing is you can stop a process immediately by using atom brutal kill. So it's passed as the second argument. Yeah, so first, before we check out the brutal kill, I would like you to know if you understand how the timeout works in shutdown. Please don't hesitate to reach out to me. I've shared my Twitter handle on my bio, so you can check on it and feel free to reach out anytime. Okay, so we can proceed. So we can immediately kill the process as well using the brutal kill. So let's see how this works. So I'll just call the process that we shall create another task because we already killed the previous one. Then call the task.shutdown, give it a task, and the brutal kill immediately. Yeah. So it immediately kills the process. So let's reduce this time and see how that works as well. So let's recompile this. I need to recompile first. After recompiling, let's create another task. Okay, so I'll just clear this again. So we already have our task. Let's call task.shutdown and brutal kill it before. Okay, it was already completed. You can try that again. So 3 seconds, let it complete. Yeah, so we can brutal kill, and if it has, so if the task is completed, it returns a tuple of an atom okay and the reply. Okay, so how can we know the task has been brutal killed, and how can we know that the timeout, it was given some time being before being shut down? So those are the two questions that has been hard for me to answer, because immediately I call shutdown and I check if the task is alive. If the task process is alive, it's always false. So yeah, I'm still thinking of the two scenarios of the timeout, which is not a bit clear for me yet. So the last point is when retrieving a result after using the task async, if you're using the task scale, it's a good idea to follow it by a task shutdown. And this I had explained earlier. The reason is if a task usually gets stuck and never completes, with the task killed, it will leave it running until you manually shut it down. Unlike with the task.await, it takes care of stopping the task. So I can demonstrate this again using task await and task killed. So let's increase our our delay to 30 seconds again. I will recompile this, first clear, then recompile. Create our task, and then let me call the task.await. So you remember the task await has a default timeout of 5 seconds. If that 5 seconds has been elapsed and it does not get a reply, it crashes and raises an exception. So with that, it takes care of the shutdown. That's how it takes care of the shutdown. So wait for 5 seconds for a reply. Was I not fast enough? Because 30 seconds is a lot. So let's try and call await immediately. Yeah, so an exception has been raised. So if we check if the process is alive, we definitely expect it not to be. So task PID. So it's not alive. So let's check how task kill works. Again, we'll create our task again, then call the task yield and give it a task. It also has a default timeout of 5 seconds. So we expected a nil because there's no reply. So in this case, we'll call the task killed until we get a reply, but will not go through that extent because I already demonstrated it in the previous series. So, okay, now we have a reply. I wasn't fast enough. But if I call the task killed, I can get a reply from there. So I'll just create another task and try to be fast enough. And if we check if the process is alive, yeah, it's still alive. So in this case, we have to manually stop the process before we get a reply back, or even after getting a reply. So that's so if you check if the process is alive, we don't expect it to be alive. That's why we have to manually stop. So whenever you're using task yield and the process might take like forever to be completed, it's always advisable to manually shut it down. In some cases, I've seen an example of calling task yield or task shutdown. Remember, they both give you a reply. So instead of yell forever waiting, you can do that. If it doesn't get a reply, it shuts down. Yeah, and that's it for this series. Thank you very much for listening, and see you in the next series.